Hi students, and welcome to today's lesson. I'm Mr. Hunter. Today we will explore the question, why does the moon look the way it does from Earth? Are you ready? Grab your pencil and your science journal, and let's get started. In our last lesson, we wondered, why is it possible for us to see a full moon from Earth at night? Does the moon emit its own light? Or does the moon reflect light from the sun? In this lesson, we will explore the question, why does the moon look the way it does from Earth? But before we do, let's review what we've learned about the moon so far. We learned that the moon orbits Earth in a counterclockwise direction. So let's draw that orbit into our model. And let's write solid arrow represents orbit. Let's also update our anchor chart. What should we add in the Earth perspective section? Let's write the moon rises and sets later each day in a monthly pattern. What can we add to the space perspective section? Oh yes. Let's write, the moon's location changes as it orbits Earth about once per month. Great updates! Your task at the end of this lesson will be to update the anchor model and anchor chart. But I'm still curious about why we can see the moon in the sky at night, aren't you? Before we can answer that question, let's review what we know about light and sight. Wow, we've learned a lot about light, but I'm still not sure if the moon emits its own light or reflects light from the sun. I know, let's draw ray diagrams to explain how the light from a full moon would get to Earth for each of these choices. Choice A will be the moon emits its own light. Choice B will be the moon reflects light from the sun. Let's start with choice A. The moon emits light. How can we draw the moon emitting light? Well, let's start by drawing Earth. We know that the daytime half of Earth is illuminated by light from the sun. So we'll add rays of light to our diagram. Now, let's add the moon. Point to where you think the moon should be. How about right here? What would it look like for the moon to emit light? I know, maybe we can draw rays of light coming from the moon and traveling out in all directions. Some of the rays from the moon could travel toward Earth, allowing us to see the moon at night. Do you think this diagram is correct? Maybe, but let's look at a second option. Okay, now what would be different on a diagram of choice B? The moon reflects light. Well, we can still draw the Earth and the rays of light from the sun that illuminate the daytime side of Earth. But this time, we should place the moon in a slightly different position, a little above Earth. In this position, rays from the sun hit and reflect off the moon as well. Some of those rays reflect toward Earth and allow us to see the moon in the sky. So which of our diagrams is more accurate? Which diagram best explains why we can see the moon from Earth? Why? Both models look like they could be accurate, don't they? I think we need more information before we can answer this question. What additional evidence could help us decide which ray diagram is more accurate? Hey, maybe if we could see images of the surface of the moon, we might be able to see if it emits its own light. One of your tasks at the end of this lesson will be to draw the diagram that represents why we can see the moon. Let's turn to the book, Look at the Stars, to gather more evidence. This book was written by astronaut Buzz Aldrin. He and Neil Armstrong were the first two humans to walk on the moon. Let's listen to what Aldrin wrote about the moon landing. When Neil Armstrong and I touched down on the moon's surface in the Eagle, we fulfilled President Kennedy's challenge. We had won the race to the moon, and the whole world watched and cheered. Nearly 400,000 dedicated people worked on Project Apollo, and I thank them one and all. It's no exaggeration to call Apollo the most spectacular scientific triumph of the 20th century. Wow! Can you imagine walking on the moon like Buzz Aldrin and Neil Armstrong? Why does Buzz Aldrin refer to the Apollo missions as the most spectacular scientific triumph of the 20th century? Well, in 1961, President John F. Kennedy challenged the United States to land astronauts on the moon by the end of the decade. And in 1969, Aldrin and his fellow crew members on Apollo 11 accomplished this goal. In order to reach the moon, scientists and engineers built a huge, powerful spaceship able to reach the moon and return safely back to Earth. Over 400,000 people worked together on the project to reach the moon. Hey, let's look at a photograph of the first moon landing. Wow! Look at this photograph. It shows an astronaut from the Apollo 11 mission walking on the moon's surface. What do you notice about light on the moon? I see shadows on the ground, similar to shadows on Earth. The astronaut's shadow falls to the right side of the picture, which means a light source must be to the left. Do you think we would see shadows if the moon were emitting its own light? I don't think so. I think sunlight must be illuminating the objects in this photograph. So, which ray diagram does this evidence support? I think the evidence supports this diagram. Do you agree? This diagram shows the moon reflecting light from the sun instead of emitting its own light. How can we update our space view model given this new evidence? Let's see. Our model must show that the moon reflects light and does not emit its own light. It also needs to show that the only light comes from the sun. Let's use our space view model materials to explain how a full moon is visible from Earth at night. In our model, Earth is blocking light from reaching the moon. How can we change our model so that light reaches the moon? What if we change the position of the moon so that light from the sun can reach it? Let's try this. How does the new model arrangement explain our view of a full moon from Earth at night? Can you track the light rays and how they are reflected with your finger in our updated model? Our model now shows that the light from the sun reflects off the moon, which is positioned on the nighttime side of Earth. The reflected light allows us to see the moon at night. How did the position of the moon relative to Earth change in this model? To see a full moon reflecting sunlight to Earth at night, the moon has to be a little above or below Earth. Otherwise, Earth blocks the light from the sun. Now, imagine you are an astronaut walking on the moon. Where on the moon would you experience daytime? And where would you experience nighttime? What do you think? Well, the side of the moon that faces the sun and reflects light is the daytime side of the moon, right? And the side that faces away from the sun is dark, so it is nighttime on that side. So, are we ready to answer our original question? Why is it possible for us to see a full moon from Earth at night? I think we are. At the beginning of the lesson, we thought that the moon might emit its own light. But the shadows in the picture of the moon landing showed us that the moon only reflects the light from the sun. So why is it possible to see a full moon from Earth at night? You will have the opportunity to draw a diagram that explains why we can see the moon. Hey, did you know that after the Apollo 11 moon landing, NASA continued to send spacecraft to the moon? David Scott, commander of the Apollo 15 mission, even became the first person to drive on the moon in 1971. Astronaut David Scott drove a lunar rover that paved the way for other rovers. In fact, in February 2021, an uncrewed rover, or a rover with no driver on board, landed on Mars. This rover is called the Perseverance, and it has sent both sound recordings and photographs of Mars to Earth. The more we learn about space, the more we are able to explore. Maybe someday you will travel to outer space, just like the astronauts on Project Apollo. Now, back to the moon. We learned this moon is called a full moon. But I wonder, does the moon always look full and round? Or does the moon sometimes look different in the sky? Your final task will be to summarize what you learned about the moon in this lesson. We'll continue to investigate the moon in our next lesson. Let's review your task for today. First, update the anchor model. Second, fill in the blanks to update the anchor chart. Third, draw the diagram that represents why we can see the moon. Last, summarize what you learned about the moon.